Hello, this is Mr. Hunter, and this is your Kinematics Notes Part 1. I gave you a capture sheet so that you can fill out these notes on the capture sheet. My other recommendation is some students don't like the capture sheet. I would recommend just having a notebook and filling out your notebook as well. And the capture sheet should be able to contain everything that I'm going to be giving you, but also students like to make additional notes. Additionally, I recommend writing any questions you have down. If you don't understand something, make a note of it because the first 10 minutes of class tomorrow, I'll be dedicating to going over these notes and answering any of your questions. Additionally, you will be getting credit for this, so I will be doing a homework check when you walk into class tomorrow. So, kinematics is the first unit we cover in physics, and physics is kind of how the world around us works and operates. Even me talking to you right now is my vocal cords vibrating together, making sound that travels through the air molecules that get into your ear. Everything we do is physics. That's why it's such a fun subject to me, and hopefully you will find it fun as well. But kinematics is the study of how objects move. Now, everything that I put on the board, you should definitely be recording. It's also a great college technique to record some of the things that I say, even if you have to pause the video, because in college classes, your professors will just be talking and writing, but sometimes they'll say some really good stuff that you need to record down. So it's an excellent study skill and strategy to record not only what's being said, but or what's also being written, excuse me, but also what's being said. So in the start of kinematics, there's these two basic principles that we have to know, and they actually will follow us throughout the entire year. So this is like I'm building a foundation, and these two terms will follow us, no joke, throughout the end of the year. At the end of the year, I will be asking you about these two terms, and they come up in every single unit. A scalar. A scalar is this new term for you, and it really just means size. It's how much it is, how large the object is, how much mass it has, how far did you go. So that's what a scalar is. It's size, and in physics we call this magnitude. So sometimes you'll see Regents questions say, what is the magnitude of this force? So that means scalar. Size is how much it is. Some types of scalar is distance, speed, time, and mass, which you know of all these terms. They're not new to you, which is also the other cool thing about physics, is most of the stuff I'll be showing you, I'll put in terms to what you already recognize. So for example, like speed, when you're in your car, that speedometer tells you how fast you're going. Now, it doesn't tell you the direction, but it says, hey, I'm moving at 85 miles per hour, which don't do that because you'll get a speeding ticket. They're not cheap. The other flip of the coin is called a vector. A vector is really just a scalar with direction. So it's size and direction. So some vectors that we know of are displacement, which I'll get into later, velocity, acceleration, force, and weight. And there's more vectors as well, but a vector is simply a scalar with a direction. So if I have speed, let's say I'm going 65 miles per hour, if I wanted to turn it into a vector, all I would say is, hey, I'm going 65 miles per hour east, or I'm going 65 miles per hour in the positive direction. The same thing with distance. I could have said, hey, I ran 100 meters down the track. Or if I wanted to give you your displacement, I could say I ran 100 meters north down the track. So that's the difference between scalar and vector, and that will come up in every single unit. Remember, scalar is just how big it is, how much of it you have. A vector is how much of it you have, but also with the direction. So here's an example of a scalar. And if you're in the capture sheet, you want to flip this over in the back and the empty space and put this down. But as I said, example of that scalar is I'm running down the track, and I only went 10 meters. There's no direction there, so it's just a scalar. Now, the vector is I ran down the track 10 meters north. So, or as we'll use later in physics, we get away from north, east, south, and west after the first 2 weeks, and we actually get into positive and negative directions. Now, the thing that I want to show you is, if you notice, a scalar is represented by a single line because it just has magnitude, it just has size. But the vector is represented by the arrow because the length of that arrow is how much it is, and the direction in the arrowhead tells you its direction. So remember, arrows are always vectors, and scalars are always just lines. And you have to remember that vectors are arrows because, as we'll do in the first few weeks of class, be doing a lot with vectors, and you need to remember to put the arrow. I can't stress that enough. People always forget the arrow, and you get points marked off for that, which sucks. So now that we've went to scalar and vector, I want to introduce to you the definition of distance. Distance is simply just how far an object travels. So, for example, I grew up in Schenectady, New York. So when I travel home from Rochester, it's approximately 220 miles. That's the distance I travel to go home. It's a scalar since I didn't provide you any direction. So I could have stopped and started. I could have actually taken a detour, which that would add to the distance, but the distance between Schenectady and Rochester is about 220 miles. The unit is in meters. In physics, we use the standard international unit of measurement, and what that means is we don't use feet, we don't use inches, we don't use pounds. We actually use meters, kilograms, and seconds. What's really interesting, about 85% of the world's countries use the SI unit of measurement. Only a few use the feet, pounds, and seconds, us including like one or two other countries. So displacement is a little different from distance. So distance is how far you went. A displacement is actually the shortest distance between where you started and where you ended. So if you go in a straight line, they're the same thing. Like when I ran 100 meters north down that track, the distance and displacement's the same. But if I take a turn in a direction, I actually will now have a different displacement than my distance. The unit is also meters. And displacement is a vector because it has size and includes the direction the object went. So for example, if I started here at this point, and let's say I move 3 meters east, and then I take a turn and I move 4 meters north, hopefully you'll recognize that this is a 3, 4, 5 triangle. I have noticed I drew it as a vector because there's an arrow and there is a length to the arrow, and then the other 4 meter north is also a vector, and then I put my end. And so like displacement, it's the shortest distance between where I started and where I ended, and that's also an arrow. Now, hopefully you'll recognize from math that this is a 3, 4, 5 triangle. So my displacement, or my resultant, as we also call it, is 5 meters northeast. Because I went over 3, I went up 4, but displacement's the shortest distance between where I started and where I ended. So quick question. What was the total distance that I moved? Give you a few seconds. Hopefully you answered 7 meters. Because if you add 3 plus 4, the total distance I went was 7 meters. The total displacement is 5 meters. So for the last part of this video, we are going to just do a quick example and be done with these notes for tonight. A woman walks 4 kilometers north, 3 kilometers east, 2 kilometers north, 3 kilometers west, and 8 kilometers south. What is the total distance she walks? Well, as we just talked about, that's really simple. All we have to do is add them up. So we can see that 4 kilometers plus 3 kilometers plus 2 plus 3 plus 8 is 20 kilometers. So overall, this lady walked or ran 20 kilometers. Now, if you said, hey, what is her displacement? That's a little different. What we have to do is actually, the best thing to do is to trace a path, because we have to figure out where she started and where she ended. So her first step was she walked 4 kilometers north. Now here I'm not writing the direction because the arrow in this case represents the direction, as long as I said up is north and to the right is east. So she walked 4 kilometers north, and then she walked 3 kilometers east, and then she walked 2 kilometers north again, and then she walked back 3 kilometers west, which, if you notice naturally, if we were to air quote add these together, that east and west just knocked each other out. And then she walks 8 kilometers south. So now we have the part where she started and the part where she ended. And as we can see, it's pointing south, so we know her direction's south, and then we just got to get that distance. Well, to get that distance, we see that this 3 kilometers knocks this 3 kilometers out. This total arrow, this total green arrow is 8. But if you think about it, she went up 4 and then she went up 2. So that equals 6 kilometers that she went north, but then she went 8 south. So since they're in opposite directions, we simply subtract them, and we can see that she went 2 kilometers south. And so it's represented by that arrow and the length of the arrow. So that concludes the first notes. I hope you guys have some good questions to bring in class tomorrow. See you tomorrow.